Okay, enough about these things. I think I'm on. Okay, let's start. In our previous class, we have talked about fractions, and we have started from the very basics, like we have talked about a fraction is a part of a whole. We have talked about that one whole figure is 4/4, or the total number of parts over total number of parts. Like if we have divided the figure in 4 parts, it will be 4/4. If we have a figure with 7 parts, it will be 7/7. All the parts should be equal to identify the fraction. Like in this case, all the 4 parts are equal. There are 2 ways of writing the fractions, like in proper equation form and in simple form. I'm not going in rest of the details because this is not the first lesson. Those who want to go from here, they can just move on and they can view the previous video that is posted on fractions, early fractions, that I'm just showing you a gist that will show you what do we mean by different sort of fractions and how we are going to explain it. We have 2 questions over here. One was slide 5 and one was slide 6. Is this a half angle, or is this a half, or if it is not a half? And I have not received many answers for that, so I'm not going to answer you right now. But before I finish this explanation, I hope that I will have viewers, and then we can move on. Otherwise, you can write under the comments that which slide is a half and which slide is not a half. So as I told you before, that if we divide any figure in 2 equal parts, it is called half. If we divide it into 4 equal parts, it is called 1/4. Similarly, if we fold the paper again and we fold it in 2 more parts, that is each 1/4 will be divided into 1/2, then it will be 1/8. This part was easy. We can easily do it with class 1. But when you're moving on to 1/3, 1/6, and 1/12, that is a tricky part because 1/3 cannot be folded easily. Okay, with the help of a strip, you can do it easily. But when you are moving on with circles and different other shapes, that is difficult part. So once you have cleared the concept with easy figures like 1/2, 1/4, 1/8, 1/16, then move on to the figures like 1/3, 1/5, 1/6, 1/12. That will be easier for you. And it is easy for the students to understand as well. The whole diagrams that I've shown you, the gist of this explanation is that if we divide anything into equal parts, that is called a fraction, and each fraction is known for the number of parts. Like if we have divided into 2, it is called halves. If it is divided by 4, it is called fourth. If it is divided by 8, it is called eighth. If it is divided by 3, it is called third, and it goes on. We can show the diagram in any way. We can color any one of the fraction, and that will be 1/4 of a circle. It can be a rectangle. It is not necessary that we are going to color specifically these 3 rectangles as blue. It can be the first one, it can be the second one, any 3 of them, whichever you are talking about. Now we have talked about the notation of the fractions. We have 2 numbers. The fraction 1/4, the upper number, that is 1, is known as the numerator, and the lower number, that is 4, is called the denominator. Denominator means the number into which the total shape is being divided, and the numerator means the total number of parts that we are talking about. Okay, what fraction of this shape is yellow? We have 4 equal parts and one shape is colored, so it is 1 over 4. Let's move on to another shape. There are too many circles, and now they are asking how many uh, shapes are yellow and what is the fraction of this shape. So can you see, count it, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 total parts, so the denominator will be 9, and we are talking about the yellow part, so we'll just count the yellow parts out of it. It's 1, 2, 3, 4. So the answer is 4 over 9. Let's have another example. It's an easy one. Again, 2 equal parts and yellow part is 1. So answer is 1 over 2. This is a little complicated figure. Okay. What fraction of the shape is blue? Now we have count the parts 1, 2, 3, 4, 5, 6. 6 equal parts. So the denominator is 6 and 2 out of them are blue. We can write it is 2 over 6. But can you see that it can be written in another way as well? If we consider these two as one diagram, these two as one and these two as one, it can also be written as 1 over 3. Okay, this is another shape and we want the fraction of purple. Purple is 1 and total shapes are 1, 2, 3, 4, 5, 6. So 1 over 6 is purple. Please remember that in fraction, the numerator number above the line indicates the number of parts selected in that object and is called numerator. And in the fraction, the number below the line indicates the total number of equal parts in which an object is divided and is called the denominator. Okay. So you can represent different fractions with the same object. Like this is one rectangle. It has 4 equal parts. So we can color 1 out of it and it is 1 over 4. If you have 2 parts colored out of it, it will be 2 over 4. We are just coloring 3 parts out of it and it becomes 3 over 4. Okay. Now again a tricky question. We have 6 equal parts and it's saying how many are yellow. You can see that 1, 2, 3, 4, 5, 6. 6 equal parts and 1, 2, 3. 3 are colored. So it is 3 over 6. But can you see these 3 is one part and this 3 is another part. So we can also say it is 1 over 2. Don't get confused. It is not very difficult. We'll be having some more examples and learn this concept. Okay. It has 4 equal parts and we want to know the color of red part. So it is 2 over 4, but again we can see it is 1 over 2. Do you understand what I'm saying? These two parts are equal to these two parts. So it is 1 over 2 as well. And because this part and this part makes 2 and this part and this part makes 2, it can be 2 over 4 at the same time. Again, a same diagram. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. So denominator is 12. 6 are colored in pink, so 6 over 12. But this can be taken as one part and this can be taken as another part. So it is also known as 1 over 2. So these are called equivalent fractions. When we have two fractions that give you the same proportion, like if we are drawing the same diagram on a square, whether it is 1 over 2 or it is 2 over 4, they will be same. Whether we are drawing 3 over 6 or we are drawing 1 over 2, they will be same. Such fractions are called equivalent fractions. Equivalent fractions are fractions that name the same amount. Can you see that? Over here, it has 4 parts and 2 are colored. So 2 over 4. Over here, there are 8 parts and 4 are colored. But the same amount of area is colored in blue. We can think of another fraction over here as well. It can also be 1 over 2. It can be 2 over 4. It can be 4 over 8. Is it clear? Okay. How can we create equivalent fractions? We have 3 over 5. And you can multiply and divide the numbers in denominator and numerator both. So you will get the same proportion to get an equivalent fraction. We can choose any number to multiply by it. Suppose we are taking 2. So 3 times 2 is 6 and 5 times 2 is 10. It means that 6 over 10 is equivalent to 3 over 5. Let's move on. 28 over 35. Again, this is a bigger number. So let's take an example of division. Both the numbers are divisible by 7. So we can divide both by 7. And the answer is 4 over 5. So 4 over 5 and 28 over 35 both are equivalent fractions. Again, fractions in the simplest form. I think it's the same thing. When we are doing any fraction, we are making any fraction to its equivalent form by multiplying, that is known as equivalent fraction. But when you are just reducing the fraction by the same numbers, by dividing the same numbers, it is called reduced form or simplest form of the fraction. For example, we have the number 4 over 5. So 2 over 11 and 3 over 8. Can you see that we cannot divide any of the numbers by with numerator and denominator? Like 4 is in simplest form and 5 is simplest form. If we are writing 8 over 10, then we can simplify it by reducing and get the answer 4 over 5. But when there is nothing common between 4 and 5, it means that they are in the simplest form. Okay, writing the fractions in simplest form. We are not going to talk about HCF over here because that is another topic. Those who have learned this topic, they must know that it is highest common factor and it is the product of all the common factors, all the common elements that are present in numerator and denominator both. That is enough for learning examples of this. But this example particularly is for those who are in higher grades. Instead of dividing one by one with one fraction, like first we are dividing it by 2, then we are dividing it by 3, then we are dividing it by 4, whatever are the common, we just find the HCF, that is the highest common factor of both the numbers, and we divide it by them. Like 20 and 22, they both are divisible by 2 and they both are divisible by 4. They instead of dividing it first by 2 and then again by 8 to find the simplest form of this fraction, we find the HCF of 20 and 28. This is two methods for this. Those who know it, they can easily understand by the written example. Otherwise, I'll have a separate class for this. And as we know that the HCF of 20 and 4 is 4. So we will just divide it both 20 and 28 by 4 and we will get the answer, that is 5 over 7. Okay. Now, anything that is not clear from equivalent fractions, we are not talking about simplest form, we are not talking about HCF and LCM, we are just talking about simplest form, then you can ask me questions. We are just talking about equivalent fractions right now. I hope that you have got a gist of what equivalent fractions are, and when we are going to solve the fractions, you will be able to do it. In the meanwhile, students of grade 2 and 3, they start practicing how to find equivalent fractions by multiplying a same number with numerator and denominator. And for grades 4 and 5, start working on the simplest form start reducing the fraction by division method. Find a fraction and start dividing by their common factors. We will look into the things deeper when we are going to talk about the certain topic in higher level. Now, as this topic is this equation is totally about types of fractions, so we are just going to talk about certain types. Like if we have a figure that is having all the denominators same, like if I'm talking about 1 over 2, 1 over 5, just let me have few fractions so we can have the example in an easier way. Okay, we can just use the slide and start with it. We are talking about like fractions. Okay, what are like fractions? If all your denominators are same, they are like. For example, if I have got the fraction 4 over 5, two over 5, let's say it's 1 over 5, these are all like fractions. Okay, whatever is your numerator, we are not talking about that. We are just talking about the denominator in 1 over 5, in 2 over 5, in 3 over 5, in 4 over 5. In all the figures, we have got the same denominator. So this is an example of like fractions. Clear? Now let's come to the next. These are your like fractions. This is another type. When we are talking about types, we have another type that is known as unlike fractions. Like if I have the same numbers, 1, 2, 3, 4, but I have different denominators. Like here I have got 8, over here I have got 7, and over here we have got, let's say, 9. Can you see? We are not talking about the numerators right now. We are just talking about the denominators right now. If the denominators are different, they are unlike. If the denominators are same, they are like. When you are going to add and subtract and multiply and divide, when you're going to move on to higher classes, then this term like fraction and unlike fraction will be used too much. If you don't know that how to identify a like fraction and unlike fraction, then you will not be able to follow the guidelines. So better understand these two things, like fractions and unlike fractions. Okay, then we have another term that is known as proper and improper fractions. When we are talking about fractions, then Everybody is talking about this is a proper fraction, this is a reduced fraction, this is a simplified fraction. So we have to talk about this. The proper fractions are only those fractions, they can be like, they can be unlike, which has numerator less than the denominator. Please remember the rule that if your numerator is less than denominator, then it is called proper fractions. Clear? But if we are talking about improper fractions, then what's it like? It's the opposite case. Now, the numerator will be greater than denominator. For example, let's make these examples as unlike fractions. If we are talking about 1 over 5 and I write 7 over 5 over here, I write 9 over 8 over here, I write 8 over 7 over here, and I write 9 over 9 over here. Are okay. There are two definitions for this. One is greater than and other is equal to. Like if 5 is less than 7, so this is improper. 8 is less than 9, so this is improper. 7 is less than 8, so this is improper. 9 is equal to 9, so this is improper. I hope you have got the point that when your numerator is greater or numerator is equal to denominator, this is the type which is called improper fraction. We can always change improper fractions to mixed numbers. Now, what is actually 7 over 7? 7 over 7 means that 5 over 5 plus 2 over 5. Okay, I'm just talking about this fraction right now. And okay, so 7 over 5 actually means these two numbers. So instead of 7 over 5, we can write 1 instead of 5 over 5 and 2 over 5 as it is. The number this 1 whole 2 over 5, this is called a mixed number. Are you getting my point? 1 whole 2 over 5 is called mixed number because it has one whole number and a fractional part. So these are few types of fractions, different type of fractions that we are going to work on in our later class. Tomorrow, same time, I'll be talking about the basics of addition of fractions or comparison of fractions, and then we'll be moving on to the rest of the topics. So let's summarize our topic. Fraction is a part of a whole. If we can divide any part equally into many parts, then we can identify a fraction. The upper part is the total number of parts that we are talking about, and the lower part is the total number of parts that we are talking about. Like if the diagram is divided into 6 parts and we are talking about one part, then it is 1 over 6. But in the same diagram, if we are talking about what fraction of this shape is 6, then it will be 5 over 6. I hope this is clear. Then next, we can draw many diagrams in the same shape, and that is very helpful in comparison that you will learn in the next class. We have talked about equivalent fractions, that any two fractions which gives you the same area in a same shape. Like if you're talking about triangles and you are dividing it into 3 equal parts and 6 equal parts and the colored area is same, that means they are equivalent. If you're talking about rectangles or if you're talking about circles, like this diagram is divided into 4 equal parts and this diagram is divided into 8 equal parts, and this 2 equal parts are colored and in this 4 equal parts are colored. So we are going to say that 2 over 4 is equal to or is equivalent to 4 over 8, or it is equivalent to 1 over 2 as well. We have also talked about reducing the fraction, that we can also find the equivalent fraction by multiplying same number, same factor to the numerator and denominator, and we can find the simplest form or another form of equivalent fraction that is reduced in number by dividing the same number from numerator and denominator. For that, we have to check that that number should be divisible by both the numbers. Like if we are talking about 28 and 35, we cannot divide it by 2 because 35 is not divisible by 2. We cannot divide it by 5 because 28 is not divisible by 5. Okay. We talked about simplest form. When the numerator and denominator have no common factor between them, then it is called a simplest form or a reduced form. We are not going to talk about HCF and LCM in this class because that is going to be the next class. Then we have talked about like fractions. Like fractions are the fractions which has got all the denominators same. Then we have got unlike fractions. That means all the denominators are different. We have another term, proper fractions, which is very easy to identify. When numerator is less than denominator, then it is called a proper fractions. If we have a number of fractions whose denominators are either less than or equal to our numerator, or we can say it in other words that numerator is greater than or equal to the denominator, they are known as improper fractions. We always have to convert improper fractions to mixed numbers in few cases, and from mixed numbers to improper fractions in few cases. Improper fraction, I have already explained. This 1 whole 2 over 5 is an example of a mixed number. If you have to convert an improper fraction into a mixed number, you have to split it into parts, whole parts separately and fractions part separately, and write it in your mixed part. How to convert mixed number into improper fraction, that we are going to talk in later classes when we have to deal with that topic. I hope I have cleared the topic. If you have any questions, Just comment me. I'll cater them in my next class. Tomorrow same time, it's going to be between 3:30 to 4 p.m. uh, Stay tuned to my channel so you will be updated with the latest videos and the latest topics. If you have any questions, if you're posting it in my group under the video, or if you're posting it in the comments under my video after subscription, then I will be answering them. Thank you very much. Allah Hafiz.